So let's talk about light and how you see light. So when you see light, it happens in your eye, and your eye converts the light and eventually goes to your brain. But that's the last step. And the steps that come before that are important too. And so that's the part I'm going to talk about today. What happens to the light before it comes to your eyes? Okay? And well, so one thing I want to ask before we really get started is, are there different kinds of light? Think about that. Are there different kinds of light? I think maybe yes. Okay. How many think yes? Different kinds of light? And then how many think no? Okay. Good. And okay, so you're both kind of right, because if you take a chair, well, there are different kinds of chairs, because they can be bigger or smaller, or softer or harder, but they're all chairs, so a chair is kind of a chair. And a light is kind of a light, but the light has different properties, just like a chair could be hard or soft. The light has different properties, and there can be several different properties. So can somebody, maybe somebody from the front row, how can you see, what's the differences in light? So what I mean is, if all the light were the same, everything would look the same, right? So if you look at my shirt, and then somebody else's shirt, and they look different, what's the difference between them? Different light, okay. Different color, okay. And then today I'm wearing a bright yellow shirt, but yesterday I was wearing a black shirt. So then what's the difference? Well, that's the color, so that's the same answer. So how about, you can see at night and you can see at day, but what's the difference between night and day in terms of the light?
Night is a lot more duller.
A lot more which?
Duller.
Duller, yeah. So that's like the brightness, or sometimes we call that the intensity of the light. So color is one property of light. Reflection back, okay. In fact, I was going to talk about that next. So the color and the intensity. But then I mentioned that the light reaching your eye is only the last step. The steps that come before that, I just heard the reflection of light. So if the light reflects off of my shirt and you see it, it doesn't mean that the source of the light was yellow or green or blue, right? It means that the shirt, or whatever the object is, has that color. So what actually happens there? Anyone know? Anyone can take a guess? What's absorbed and what's reflected. So the light source, not all light sources, but the light source can have all different colors, and then the object that it's reflected off of absorbs some of the colors and only reflects. So the color that it reflects is the color that you see. So that's how we ultimately see something. So we know that we can see the light with our eyes. It can have different colors and different intensities, and we know that it reaches our eyes by reflecting off of different things. Okay? So there's another property of light besides color and intensity that I want to tell you about. So if you have, did everyone get at least one of these, right? Yours are maybe a little bit smaller.
They look like
yeah.
35 millimeters.
Okay, so this is first experiment. Okay, so when we do experiments, usually what we do is we try to guess what we're going to see, and then we look, and then if we don't see what we expected, then we change our idea and maybe try something different. Okay, but for this first experiment, I'm going to describe to you what to try. So hold your square. So these are polarizing slides, and look at all of the displays. So we have actually 5 different displays, and then slowly, while you're looking at one of them, turn the slide while you're looking through it. Okay? And so maybe try it on the top one, and then try it on the bottom one. And try it on the middle one, maybe. Okay. Did anyone see something special? How about on the top display? Did anyone see something special? What did you see?
I saw that I looked at this like this, at that one,
Uh-huh.
but it didn't turn anything. Then I looked at the bottom one.
Okay. When you turn it, well, only at one angle, it goes completely dark, right? In fact, I checked ahead of time. The top right and the top left both do that. Okay? Did you want to say something? The spoon didn't move? Okay. You're right. I agree. Spoon didn't move. So on this one, though, it gets darker, right? Did you try that? Okay. Okay, so I hope mostly everybody was able to see that. Anyone not? Okay. So that's our first experiment. Now I'm going to show you almost the same experiment over here. So I have it's gone dark here.
Just touch it.
Ah, there we go. Okay, so this property of light that I'm describing to you, it's called polarization. So for color, there are an infinite number of different colors. For polarization, there's just two. So this is another polarizing sheet, just like the one that you have. And I'm going to place it over the light source here, so you can see that I just did that. So the screen got just a little bit darker. And then I'm going to place the second one on top of it. Well, maybe this one, because it's a little bit bigger. If I place it in the same orientation, so what happened? Did it get darker when I put it down? Maybe a little, but only a little bit, right? But now, okay, so here's your chance to make a prediction. What happens if I turn the polarizer on top and leave the bottom one the way it is? Say again? Try again. What happens if I turn the top polarizer and leave the bottom one as it is? Will it get darker or stay the same? Stay the same? How many think stay the same? Okay. And how many think darker? Okay, so let's try it. So it gets darker. In fact, it gets a lot darker. And, okay, so the light that gets through the first one gets blocked by the second one. So I just told you something that we know because we've been working on this for a long time, is that the light comes in two polarizations. The first one lets it through and the second one blocks it. Okay, so now I'm going to take a third one and I'm going to lay it on top of the first two. Can I make the light come back? Who thinks I can make the light come back? Okay, and who thinks not? Okay. I always get votes on both sides. So here we go. Put it on. No. But this is an experiment, right? So if I don't get what I wanted or what I expected the first time, I should try something different. So what should I try differently? Rotate it? Okay, let's try that. No, it didn't get any brighter. Rotate it some more? Okay. Yeah, it doesn't work anyway. Okay? Okay, so putting the third one on top of the second one didn't bring the light back. Actually, that's the way it works. Once the light is blocked, you can't unblock it with the third one. But there's still something I haven't tried. Can anyone think of what else I should try? Is there something else? Okay, TJ, what should I try?
Try turning it a quarter of the way.
Quarter of the way?
Maybe
I
the
think I-
second one.
Oh, no, but I'm going to leave those fixed. Okay. Turn it over, that's a good idea. Let me give you a hint. I tried putting it on top of the second one. What about if I put it underneath the second one? So I won't rotate the second one, but I'll put the third one underneath, and you can see what happens. Now it lets the light through. Okay? So this, for me, that's about the closest thing to magic. Suddenly it lets the light through, even though it blocked it before. Okay, so I'm going to have to tell you some more things how that works. Okay. Now here's a really hard question. Maybe some of the adults know, but I'll give the kids a chance first. What is light made of? Color, yeah, that's a good answer. Okay, I'll give you a different hint. If somebody does this to you, what are they doing? They're waving, right? So what is light? It's a wave, yeah. So when we go out on the water, yeah, that made it really easy. When I go out on the water, you see the waves on the water, right? Yeah. So I'll make a simple wave like this. Okay? I didn't bring any water, I'll have to bring some water. But, okay? So there's a simple wave. Now look at my fingers. Okay? Which direction is the wave moving, by the way? I'm trying to start off at that elbow and go to the other elbow. Is that what you see? Which direction is the wave moving? Just point. Somebody point. Which direction is the wave? That way? Yeah. Well, somebody's pointing up, okay? So the wave is moving that way. But watch my fingers. Are they also moving that way? No, my fingers are moving up and down, right? Okay, so this is the way this kind of wave works. The water moves up and down, but the wave moves side to side. Okay? Now, so that's an analogy because light is not water, but it's an analogy. Another analogy is a string. So here's a nice chord, and a string can make waves too. So I guess Dave's gonna shake it, and I'm gonna explain. Okay. So you can make it go this way, or here, why don't I rotate it? So you can go the other way. Yeah, I'm sorry. Okay.
That's why I'm here.
Yeah, he'll do it.
Do you want that?
I just want to go the other way. Yeah, get them lined up. Okay. Or it can shake the other way. Okay, so this is the polarization. It's
No, I'll take care of it.
okay. This is the polarization. The light and the string are similar in the sense that they can go one way or they can go the other way. All right, so now what are the big wooden things? Go ahead.
Polarized.
Yeah, the big wooden things are our polarizing sheets. Now these have just one slot in them for the string to go through, because this is just an analogy to one wave of light. Okay. Now, if the two polarizers are the same way, you can see that the light gets all the way through to here. But if there are different ways, okay, go ahead and rotate that one. If there are different ways, We adjust it just right so that they're crossed just right. Now what happens? What do you see? Almost nothing, right? So the light makes it through the first, but it doesn't make it through the second. So that's the way the polarizers work. It's almost a perfect analogy with the swing. Okay. So now let's get back to how we see light and how it reflects off of things. I think there's just a minute of setup. So we're going to do the
Are you doing the third part?
I think we're going to do the black plastic first. Let's see if we can. Okay, so I'll talk while David's setting it up. Okay, so we couldn't bring the lake inside, but it turns out that black plastic, if you crinkle it a little bit, it's kind of like waves on the lake. And then our desk lamp is kind of like the sun. Do we want to make it? Do we make it so that people can see the lamp?
Oh, yes.
Yeah, do you like it that way? Yeah.
Everyone
Okay.
can kind of see the bulb to some extent.
So let's see if this works. So again, everyone has their polarizing sheet. Now what I want you to do is look at the lamp and then also look at the plastic. So I think, can you see some of the light reflected off the plastic? I'm going to try it too. I haven't tried this. Can you see some of the light reflected off the plastic? And then when you rotate at some angle, the reflection off the plastic goes away almost completely. Yeah. But if you look at the lamp doesn't really change. Am I right? Okay. So let me ask the kids. When you rotate it, does the light from the lamp change, or does it stay the same? When you rotate it. Do you think it changes a little bit? Okay. And then how about the light from down here? Okay. And then how about the light from down here? Does that change? No? Maybe you're close. Okay. Does anyone else see the change on the plastic? Okay, I think most people can see it, right? Okay. So the light you're seeing that's reflected off the plastic, is it polarized? Yeah. It's a lot more one way than the other. So this is what happens outside, the sun reflecting off of the water, or it could be a car windshield or anything. In fact, it could be black plastic reflecting the light. The reflection tends to be mainly the light that shapes this way, and not the light that shapes this way. Okay, so this is one polarization that comes through to you, and the other one that doesn't. Okay, so normally you can't see that, but with special glasses you can. Okay? What kind of glasses are these? These are sunglasses, right? But these, not every sunglasses are polarizing sunglasses. These are polarizing sunglasses. So if I take the lens out and put it there, you can see it. It's too dark. Oh, I know, I have a polarizer in. I put the lens in. I still can't see through it. Well, I'll just look through it at you. Maybe someone can verify this for me. If I put the lens, is it okay? Can you look through? Can you see through both lenses? Okay. And then how about now? Can you see through both lenses? No. Okay. So these lenses are polarizing lenses. They're a little bit tentative. That's why it's hard to see through than on the screen. But they only let through the light that shakes like this, and not the light that shakes like this. So that's why the black plastic gets darker. That's what we call glare. And the polarizing sunglasses, this is not an advertisement for polarizing sunglasses. They're kind of expensive. But they block the glare, which is the light that shakes the light this way. Okay? Okay, so we managed to do that. Now let me come back to the other effect that we talked about. Remember, I hope you remember, when I had the 3 polarizers, and then we put the third one in between the first 2. And there was the light that got blocked suddenly came through. I can demonstrate that again. Yeah, let's. Okay. How much time do we have?
Technically, we're better.
I got 11:24. Okay, a couple minutes.
Still fine.
Okay, let's see if we can do this one quickly and illustrate that. Okay, so just to show you quickly, and then we'll wrap it up. So now we've got 3 different polarizers. Okay, I can hold the other end. Okay, I'll just hold it here. So now we've got 3 different polarizers, and you can see what happens. The second one actually guides the light, and so now it actually makes it through the third one. Can everyone see that? Whereas before, if we just had 2 and they were crossed, it didn't make it through. So that's how it works. The polarizers can actually rotate the light, and this is how the liquid crystal displays that the flat panel displays are made from works, and that's what this is about. If you have molecules that are like popsicle stick shaped, and they're aligned, they can act like polarizers, but some of the molecules like to spiral, and the molecules can actually rotate the light, and that's how the flat panel display can go from light to dark. They can go from either rotated like this to either random or all the same direction. And so that's just a quick explanation of how the flat panel displays work. You can learn a lot more of this at the tables outside. We have graduate students manning the tables. And before I forget, should give Dave a hand for making all the equipment work. Thank you very much.
Kids, if you want to keep the Polaroid, you can. I'll ask the adults to put theirs back because we have another thing this afternoon. I want to make sure we have enough to hand out. So, welcome. Hold on.